Have you ever wondered how randomness and uncertainty are modeled in computer science? The answer lies in a fundamental concept of probability theory known as a probability space. A probability space is a mathematical model that comprises three elements: the sample space, the event space, and the probability measure. The sample space is the set of all possible outcomes of an experiment, such as heads or tails when flipping a coin. The event space is a collection of subsets of the sample space, each subset representing a potential event. And the probability measure assigns a likelihood to each event, quantifying the chances of that event occurring. Together, these elements enable us to model and analyze random phenomena in a structured way. So the next time you're working with algorithms or data structures dealing with uncertain outcomes, remember, it's the underlying probability space that's doing the heavy lifting. Therefore, a probability space is a mathematical model that helps us understand and quantify uncertainty. Now that we understand probability spaces, let's delve into the concepts of measure and distribution. A measure in the realm of probability theory is a function that assigns a non-negative real number to subsets of a given set. Think of it as capturing the size or volume of those subsets. In the context of probability spaces, we use probability measures to quantify the likelihood of events occurring. Now, let's talk about distribution. This is a function that assigns probabilities to events in a probability space. It's like a map that tells us how likely each event is. For example, if we have a fair six-sided die, the distribution would assign a 1/6 probability to each side of the die. So in essence, a measure helps us quantify the likelihood of events, while a distribution describes how probabilities are assigned to these events. This understanding forms the foundation for various algorithms and models in computer science, allowing us to effectively analyze and navigate randomness and uncertainty. And to better understand these concepts, let's look at a few examples of distributions. First, the uniform distribution. Imagine rolling a fair six-sided die. Each outcome from 1 to 6 has an equal probability of 1/6, exemplifying a uniform distribution. Next, the Bernoulli distribution. Picture flipping a biased coin. The outcomes, heads or tails, are assigned probabilities p and 1 - p, respectively. This scenario illustrates a Bernoulli distribution, modeling experiments with two possible outcomes. Finally, let's discuss the normal distribution, often associated with the iconic bell-shaped curve. Consider the heights of adult males in a population. This continuous data set, which can take on any real number, follows a normal distribution with the probability density function shaping into a bell curve. These examples give us a glimpse of how different distributions can model different types of random phenomena. As we wrap up, it's clear that understanding probability spaces, measure, and distribution is crucial in computer science. These concepts form the backbone of various branches like machine learning, data analysis, and cryptography. They allow us to effectively model and analyze the inherent uncertainty and randomness in these fields. The mastery of these concepts equips computer scientists with the tools to navigate the complex and fascinating world of randomness. So the next time you come across a random event in computer science, remember these fundamental concepts and you'll be well equipped to handle it.